All right. So now it's being recorded. Is the screen share part of the recording, I wonder?
Yes. Yeah,
Okay.
it would be the I don't know if the camera stuff shows up or not. We'll see. But I know it does if you uh take it off screen share, but
Mhm.
no, it'll show it in the corner. Yeah, so it'll show the camera in the
Mhm.
corner. Think of the person speaking.
I'm gonna go, just in case it's me controlling, I'm gonna go active speaker. Okay. Cool. So, um, welcome back to Crafting Interpreters in Rust. This is the first session where we're gonna actually code stuff. Starting with chapter 4 on the scanner or lexer. I figure I will just start reading through, and then when there's a code snippet, I will copy and paste and adapt it or whatever the process needs to be. And we'll just make our way through. And if it turns out that that's like kind of a weird whiplash, like read a section and then edit a code block and then go back and read a section, then in future we might just like read through and then port after. But for now, I'm trying this. So, all right. I will go ahead and start the live share of the code. Make read only. Okay. So you are free to join via this link. And I'll go ahead and get started. So, scanning. The first step in any compiler or interpreter is scanning. The scanner takes in raw source code as a series of characters and groups it into a series of chunks we call tokens. These are the meaningful words and punctuation that make up the language's grammar. This task has variously been called scanning and lexing, short for lexical analysis, over the years. Way back when computers were as big as Winnebagos but had less memory than your watch, some people used scanner only to refer to the piece of code that dealt with reading raw source code characters from disk and buffering them in memory. Then lexing was the subsequent phase that did useful stuff with the characters. These days, because reading a source file, reading a source file into memory is trivial, so it's rarely a distinct phase in the compiler. Because of that, the two terms are basically interchangeable. Scanning is a good starting point for us too, because the code isn't very hard. Pretty much a switch statement with delusions of grandeur. It will help us warm up before we tackle some of the more interesting material later. By the end of this chapter, we'll have a full-featured fast scanner that can take any string of locked source code and produce the tokens that will feed into the parser in the next chapter. The interpreter framework. Since this is our first real chapter, before we get to actually scanning some code, we need to sketch out the basic shape of our interpreter, JLOX. Everything starts with a class in Java. Okay, so they got a class locks with a main function, and the function can throw an exception. I will take this and put it over here, and then figure out how to make it Rust. So this is, I'm going to need the command line args. For now, I'm just going to use that.
I pasted a crate that performs this specific task. It will also generate a nice help message.
Your crate,
Yes.
the path, yeah.
It's
Well,
exactly
I'm gonna
that problem.
do things the basic way. Later, if the arguments become much fancier, I'll use a special crate for it. So we're gonna get the args. Here's my headphones. Okay. So if you don't have any args, then we're going to tell you to provide the args. And we're going to, I guess,
Didn't that say
return.
if args is less than 1 or something? Or less than 2, or I don't know.
Yeah, this is supposed to be greater than 1 here because it's saying if you provide more than 1 argument, then you're doing something wrong. So the way it's
The
supposed
only
to work
argument is
is,
the name of the thing you want to run.
yeah,
Only
the
one.
script.
Okay.
So if you don't provide any arguments, then it'll run in a REPL mode. So it'll, just like if you type Python without any arguments, it'll start running like a place, like a command where you can type Python code and have it in. If you provide 1 argument, it'll run that argument as a script, like interpreting it as a file name. If you provide more than 1, then it is an error, or like it'll print out a useful like a how to use locks. We're just going to call it locks, I think, and return. So that is .len instead of length. Then and we have a function called run file. And it takes the name of the script. Which and doesn't return anything. Unimplemented. And we're going to have a run prompt, which takes nothing and returns nothing and is unimplemented. All right. This syntax Rust doesn't like, so I think it's .nth 0. And what is wrong with that? It's an option. So it's not just the 0th argument, it is an option containing it. So we're just going to assume that we have it. All right. Our args as mutable.
First argument is usually the application name. So version for Java does something else. You have to check if it's greater than 2, if it's equal to 2, and otherwise fail. Or just use the code I pasted.
Well, then okay. So let's look at this code. I'm trying to get it done. I'm trying to use few dependencies though. Or use dependencies only as they are absolutely needed. So which parts of this code is this supposed to replace?
Okay, so you need to add the crate itself, you need to add the use, you need to import path both, or if you want to use string, that's also fine.
What are you talking about?
Do you even have a crate? Yeah. You probably want to update the more recent Rust that uses faster fetch.
I think I'm just going to use the regular way. We can revisit this to see how much cooler it is. Right. So I heard what you were saying though, which is that the first argument here is going to be
the application name.
Is going to be locks and not the name of the script.
Yep.
So nth 1, 2, and then what's it still complaining about here? Why do I need to, why does it think I want to mutate args? if I just wanna
You're
get the
trying
answer?
to use it as an iterator.
Okay. Oh, right, this is initially an iterator. Args
You
dot
can try
collapse.
collecting it a vector.
Okay, gotcha. And then this one, you think this one can still just be, use that syntax?
You don't need unwrap, but yeah, that might work.
All right, yeah, sure.
And you need clone.
Can I just do that?
You need to use reference.
Cool. So let's go ahead and do this. Make sure we're getting it. So let's make a test. Oh, look, I already made it. How about that? So Rust. Sorry, Rust is like a little alias I have. Get rid of this for the moment. Files. All right. So not implemented. That's because I didn't. Now why did it think? Okay, no, it worked. It worked. This is printing the name of the file. This is panicking at not implemented. So that's good. We just do the program. The panic's there. Let's say okay, REPL. And then if I do more arguments, it prints the usage. Okay, all good. All right. For exit codes, I'm using the conventions defined in the Unix header. Okay. Stick that in text file and go get your IDE or makefile or whatever set up. I'll be right here when you're ready. Good. Okay. Lox is a scripting language, which means it executes directly from source. Our interpreter supports two ways of running code. If you start JLox from the command line and give it a path to a file, it reads the file and executes it. Okay, so I'm going to call it the same thing as he calls it. Oh, I didn't. All right. Okay. So we're this gonna get all bytes of file and then convert bytes string and then call run on string. So this means we have another thing called run, which is actually running the interpreter. So I'm going to say this is, what's he called the, yeah, he calls it source. I'm going to say source. I'll try to do answer if it becomes necessary to make a string later. I will do that. Okay. Let's see. It appears that you can also fail to run. So I'm going to have this return a result. And the error type, I don't know. It's not really, what should the error type be?
You can
Doesn't
use
matter.
anyhow, you can use Boxstein error.
Does that, and Boxstein error means like, it's
Pretty much
dynamic, so
you,
it can be
you
anything.
can use format if you want to display user-friendly errors.
What's the error come from? Oh, the trait. Okay.
STD error.
Error. Okay.
If you have Rust Analyzer configured correct, you just type whatever you want and it will suggest the import from crates you have.
I'll try that.
I would define type alias for result with error pre-applied. So you don't have to type all over the place.
Sure. Okay. So type result equals
Result T.
Yeah, T equals result T
Yep.
box error. So
STD result,
Yeah.
or STD core result.
It's core.
STD
Option. And it looks like
STD result.
Yeah, there we go. All right. So this is just a result of returning nothing. So we're gonna okay. All right, so if everything goes well, we'll return okay. Otherwise, we'll at some point return error something. If I want to populate a box-Stein error, do I need to like create a
You
box
can
and stuff?
allocate a string and just run int on it. I think that works.
Okay, compiler's happy, so I assume that will work. All right. So let's do a read all bytes of file.
stdfs read to string.
Yeah, do you want the read to string?
All right, okay. Yeah. If you know the right import, maybe you can try putting it up here.
I usually just type stdfs read to string. You use it just in one place.
Yeah. All right. So let s equals. I like a. I like getting it all the way down to here. I don't really like the absolute paths in your code. That's just me personally, though.
Up to you.
So this gives an IO results.
Question mark.
Yes, right. So why does the... So I know what question mark's supposed to do. It's supposed to, if it messes up reading to string, it'll just bubble that up.
Yep.
But I guess this is something I've never really had to deal with before, like writing industry Rust, where the error types, you have to get the error types to match up. So
yeah, you can return the result from main as well.
Yeah, that's true.
And you need question mark in run file too. You want question mark and a K at the end. No. So
I see. I'll get it.
yeah. That should do the trick, I think.
And then we're probably going to do the same.
Above that doesn't return anything.
Yeah.
You can change print line to return the error instead.
Well, I mean, then it'll get then won't it look like an error panic instead of just a clean printout?
Maybe. Well, if you use bpuff, it would be clean printout.
All right. Okay, so we have the string. Don't need that, I believe, because it's just regular string, right? Yes. And then we're going to call run on S. Okay. Cool. So that's that. If you want a more intimate conversation with your interpreter, you can also run it interactively. Fire up JLocks without any arguments, and it drops you into a prompt where you can enter and execute code one line at a time. An interactive prompt is also called a REPL, pronounced like rebel but with a P. The name comes from Lisp, where implementing one is as simple as wrapping a loop around a few built-in functions. Read, eval, print. Working outwards from the most nested call, you read a line of input, evaluate it, print the result, then loop and do it all over again. All right. So for run prompts, going to also return a result. Okay. Okay, open input stream, and then forever, which here in Rust is called loop. You're going to print your, your prompt character. You're going to read line. If line equals null, break. I guess we can try it. We can see if we need.
So if the user just hits return, then that's the end of that's like their control D and they're done with the interpreter.
Yeah, except, I mean, that's not how Python works, right? In Python, if you do return, it'll just do that.
Right.
So, and you need like a special.
They've made another choice.
Yeah. So in that case, would line actually be null, or would it be, I guess if it's delimited by new line, then it would be null if you just hit enter. All right.
Or maybe, oh yeah, they're saying in the Java world, you would hit Control D and then it returns null when the EOF is hit.
Yeah. So Control D makes an EOF.
I think it's going to be easier to implement something that runs the code first rather than doing interactive stuff.
I'm just trying to get the framework, but yeah. You wanna. I'm trying to implement it in the same order that they're implementing in the book. That's all. We can say like if line equals exit, right? Something stupid like that. Great. Okay. So line equals. So I need an input stream. Read. Okay. So this is. So this will give me a handle for standard in from which I can read line into a string. That's okay with me.
Which may or may not be as it might be excessively buffered. It might wait for 1024 characters before applying any of them. I don't know. I have no idea how it works.
I have no idea, but read line, I would assume by default delimits by new line character.
You can get STT in locaten then just call lines iterator on it. Should be fast
that
enough for practical
sounds-
applications.
That sounds very nice. So for line in. So what's the point of the so this would be standard in.
Lock lines.
So what is the point of the lock?
By default, it takes a mutex every time it performs an operation, and that is slow. By using lock, you just take this mutex and operate with that without dealing with it.
Are you sure? Is this the
You
right?
need to-
Is the right standard in?
Yeah, you need to import a few things.
Does it need to be capitalized or something?
You
No.
need to import std IO buffer it.
Yeah. Okay. So this is. Let me see if I could have figured that out from the compile errors.
Well, it says so in green.
So it suggests the same thing, but why do I need that? So this
Because
line
lines is the method of a trait, and to use method of a trait, you need to have the trait in scope.
So lock is a buffer read.
Locked is std in lock,
Which implements buffer read.
which implements a few traits.
Okay. Well, that's indirect. I'm glad that the compiler knows enough to suggest it. All right. So cool. So now I have
A line you get back as a result, so you have to use question mark. Let line equal line question mark.
Sure. That makes sense. All right, so trying to parse, try an error trying to get the line will bubble up. If it's a break. Now, will this work with our sort of prompt character? Let's just see.
And then you need to call run on that line.
You need to flush std out, I think.
So that doesn't. The standard IO stood out dot flush.
Yeah.
Why do you need to flush it each time?
Because printing is expensive, it needs to take a lock as well.
This is more complicated than the way that I did when I was like preparing. So why isn't it working the first time? I need to like print.
You probably used print line that flashes automatically.
I don't want to use print line though, because I want it to be this prompt character and then you type after the prompt.
So you need print and flash then.
I did that. It doesn't appear to print the prompt first. See, no prompt. I hit return, and there's a prompt. So that's because we're taking a line from standard in first.
You need to.
So I'd rather not do it this way. I'd rather just loop and then take a line from standard in after the print, and right.
Well, you can use that.
Right. So I'd rather just like loop and then get a line from standard in here.
you will be using the same iterator.
Yeah,
Like, for that, you need to define it outside of the loop as mutable.
yes, you are right. All right.
And do you want to dot lock it
You,
way up
you
there?
still want lock and lines.
Right. So then it'll already take the lock and already start making the iterator of the lines right there.
Okay. But then,
Lines.
And then how do you get just the next one from standard in?
yeah, that's
Standard in dot next. It's an iterator.
Cool.
every
I'm
iterator.
absolutely
of
new
this.
to Rust.
It gives you back options, so you use if let, for example, or let else.
Option results. Oh, right. Okay.
Yeah, it's an iterator, so it's next
Yeah.
option.
Um,
So I would use let else. It should look like let.
that's a thing. Else.
Yeah, so you need to use some around line and else like return. Yep.
That's it.
And
Wow. I've
return
never
unit.
heard of that. So else.
Return unit, return OK unit here. And get rid of the curly braces before else.
What?
And semicolon, yep.
Why is this a thing? I like a okay. Why isn't it formatting it? Is this like a new version of
you
Rust?
use alt Rust.
Okay.
Okay, flash can fail. You need question mark.
Yeah. Do I still need to flush?
You still need the flash.
Okay. When I did it before, I didn't. I got this working without needing that. All right. So exit. Cool. It works. All right. It must be because of lock. I'm pretty sure the way I did it before was like just that. And then not this. And then I would do the read into a buffer, read line into a buffer. Oh well. It works. So let's put something in here. Running on source. Okay. Cool. All right. There we go. Thank you for all the help. It's one thing to do this on your own, and another thing to do it with while something's recording you. So all right. So the read line function, as the name so helpfully implies, reads a line of input from the user on the command line and returns the result. To kill an interactive command line app, you usually type Control D, blah, 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 blah. We know that. Both the prompt and the file runner are thin wrappers around this core function. So run, given a source, we will make our scanner object. So here's where our make a scanner. Get scanner, get tokens from scanner. And then do something with the tokens, print tokens for now. Okay, so we need a scanner. Let's see, maybe I'll read a little bit more and then make the scanner struct. It's not super useful yet since we haven't written the interpreter, but baby steps, you know. Right now it prints out the tokens our forthcoming scanner will emit so that we can see if we're making progress. Error handling. While we're setting things up, another key piece of infrastructure is error handling. Textbooks sometimes gloss over this because it's a more a practical matter than a formal computer sciencey problem. But if you care about making a language that's actually usable, then handling errors gracefully is vital. The tools our language provides for dealing with errors make up a large portion of its user interface. When the user's code is working, they aren't thinking about our language at all. Their headspace is all about their program. It's only usually when things go wrong that they notice our implementation. When that happens, it's up to us to give the user all the information they need to understand what went wrong and guide them gently back to where they are trying to go. Doing that well means thinking about error handling all through the implementation of our interpreter, starting now. Having said all that, for this interpreter, what we build is pretty bare bones. I'd love to talk about interactive debuggers, static analyzers, and other fun stuff, but there's only so much ink in the pen. All right, I'll go back up here. So I'll move I'll do code organization later, I think. I won't fuss about that, kind of boring. So what does the scanner need in it? Almost nothing for now,
The
because
source.
it just needs, well, the source can be fed into the new method. I guess it will have to keep the state of the source because we're going to make an iterator over tokens. So yeah, maybe inside it'll probably just have. Okay, there's a lot of different ways to do this. Do you think tokens should be a separate struct that implements iterator, or do you think scanner should implement iterator?
Scanner should implement iterator. Scanner needs to hold the leftover input inside, and tokens should be enum with whatever it implements.
Right. Okay. So we have an enum for tokens, which will have all the different types of tokens there can be. And then the tokens is
A scanner contains input as the reference to string.
okay. Should it be called
I
source?
complain about lifetime, so you need to add like lifetime A to scanner and annotate input with this A.
Right. Yeah. Is there any way I can possibly think about lifetimes later? Just because one of the things that what I like about Rust is that it will make you immediately confront all of the implications of your code. But, you know, what if I don't want to? What if I just want to do it in a way that's like the most straightforward right now? Can I even? So
With those things like strip prefix, which naturally works with string slices. But to deal with strings, you will have to convert back and forth.
mhm.
So I would deal with the lifetimes. It's not a huge problem.
So, right. So I make a reference.
Ace space, and right after scanner in triangular braces, it's prime A. Yep.
Okay, you don't need to.
You don't need to.
If you for this one won't you need this there.
Yes.
That I don't get yet. Why does it need to be there?
Yes. If you want to talk about the lifetime here, yes, but you don't have to.
So is all that need to do is just assign it to create the struct. The
I
source.
would call this parameter input as well.
So it's called source here. Why would you change name? Just
Mm,
because,
just because it's called inside as input, but up to you.
what did they call it here? Class scanner. They call it source. I'm gonna call it also source.
Okay.
Because so
In
that
that
the
case, you can
translation's
change
easier.
the input into
Yeah.
source as well. Okay, so lifetime of source is also A,
Sure. So scanner
and
with
just source in
source.
curly braces. So good.
Okay.
Next, we want to define iterator for that.
Yes. So tokens.
You can have, you don't have to have tokens as a separate function. You just create new scanner, it's already an iterator. You can consume items from them.
Okay, so we would just say scanner.collect maybe.
Yeah, if you want
Okay.
to collect it and the vector.
So this means impl iterator or scanner.
Yeah, you need to specify lifetime here and the lifetime before. Yes.
Here.
Yep.
Oh man, I don't get it. I don't get that.
Now you need
It's
to
feels
ask Rust Analyzer to implement missing methods.
yeah. Let's see. What is there? Is there like a Rust analyzer? Rust analyzer. Oh shit. See, this is useful to know these.
Yeah, that's why I don't like GUI stuff.
Well, I don't know what it's even called. Implement. All right, whatever.
If you right click on the error, will it suggest anything? Implement missing methods, okay.
Okay.
So
Now,
item is going to be token with lifetime A.
so type item
Yep,
equals token.
token with lifetime A.
So it doesn't. What's wrong about
You
that?
need to add lifetime annotation to token as well. All the string references are going to be string references. Okay, and what kind of tokens do we need?
We will see. So here's all the token types. I guess I can just take them over. So he has an enum called token type, not token. Is there any reason to have one or the other?
They have fancy names in Java. I prefer it simple.
Token type. Let me see. So, but he has two different things, right? So the scanner he has a class token and then an enum token type. So what does the class token have that token type doesn't? It's got a type, lexeme, literal, line. So I think, don't we want these to be two different things?
That's Java.
So if it is in Rust,
So would you make them the actual tokens have the those like the string and object and the line and all that? Or,
No, don't we need a struct token that
No,
has
why? We
one
can
of
keep
these?
data inside the tokens. It's not a problem. And we can keep token
You
copy.
mean so that this has the token type and then a couple other things attached
Do
to
they
it.
have some types in Java?
Well, they have
So that's why.
enums. No, I'm not. I'm not understanding what you're saying because we have all these.
Yep.
We need we need essentially just like a bunch of these tuples.
Okay, why?
Right? Well, because that's what he's got. That's what all the data associated to one type of token.
Yeah, that's a limitation of Java. So like Sam,
Yeah.
we're going to keep it inside. What is it? String literal, or what is it?
Alexim.
Yeah.
Well, we'll get there, but I assume it is something like, yeah, the string literal that maps to it. Let's see what if he defines. Yeah, so group them together group the source into the smallest sequences that still represent something. Each of these blobs of characters is called a lexeme. So that
Okay.
the token, the list of tokens, each one is going to have which type of token it is, and also the lexeme, which is which bit of source is that token.
Okay, we can. Well, let's make a struct token then. So this one is going to be token type.
All right. So this is type. Type is keyword.
It's going to complain
so
on type.
token type lexeme string.
String slice. And lifetime A, and you need lifetime on token type as well.
Why do I even need lifetimes here?
String literal, or is it, we're not going to keep it inside?
So
Maybe.
this is just a whole lot of identifiers for types of tokens.
Okay.
So I don't think it needs to know about the lifetime yet. What else do we have? Class token. Oh, object. As in like the Java. Okay, goodness.
I
What
think
is an
that's
object?
string literal and number literal, and those should go inside the token type enum
Okay.
in the literal constructor.
so are they using the object because it's going to be some very general,
Let's
a literal
find out.
very general?
Why don't I read up through here? Because then it might help us figure out how our implementation
Yeah.
should go. So I'll get back to error handling. This seems all right. Okay, here's a line of LOX code. Var language equals LOX. Here, var is the keyword for declaring a variable. That three character sequence var means something, but if we yank 3 letters out of the middle of language, like GUA, these don't mean anything on their own. That's what lexical analysis is about. Our job is to scan through the list of characters and group them together into the smallest sequences that still represent something. Each of these blobs of characters is called a lexeme. In that example line of code, the lexemes are var language equals lock semicolon. The lexemes are only the raw substrings of the source code. However, in the process of grouping character sequences into lexemes, we also stumble upon other useful information. When we take the lexeme and bundle it together with that other data, the result is a token. It includes useful stuff like token type. Keywords are part of the shape of the language's grammar, so the parser often has code like, if the next token is while, then do. That means the parser wants to know not just that it has a lexeme for some identifier, but that it has a reserved word and which keyword it is. The parser could categorize tokens from the raw lexeme by comparing the strings, but that's slow and kind of ugly. Instead, at the point that we recognize a lexeme, we also remember which kind of lexeme it represents. We have a different type for each keyword, operator, bit of punctuation, and literal type. After all, string comparison ends up looking at individual characters, and isn't that the scanner's job? All right, so we have all these token types. Literal value. There are lexemes for literal values, numbers and strings and the like. Since the scanner has to walk each character in the literal to correctly identify it, it can also convert that textual representation of a value to the living runtime object that will be used by the interpreter later. Location information. Back when I was preaching the gospel about error handling, we saw that we need to tell users where errors occurred. Tracking that starts here. In our simple interpreter, we note only which line the token appears on, but more sophisticated implementations include the column and length too. Okay, I'm noticing time really flies when you're programming, more so than when you're reading. So we're gonna have to call it in a bit. But I think that answers the question of what is this literal here. The literal is like if it is an identifier, a string, or a number, the actual value. So it has to be either, I guess, at this point, is it going to be an enum, which is either a string or a number, or is it just going to be a string because it still only exists in the form of the program?
Numbers, I think, will parse into F64, but identifier and strings will remain string slices.
Okay, so we need another enum for it,
Do we?
right?
Yeah.
Why don't we put it inside token type?
Well, isn't it going to change per token? You'll have two different string, or you'll have two different number literals, and they're going to have different actual values.
We going to use just one F64?
Yeah, don't we just, doesn't locks only use F64?
I'm not talking about the type of the literal. I'm talking about as we're parsing the code, we're going to chunk off it, like we've reached the part of the code where there's a number literal. This
Yep.
one is the number 5. So
Yep.
we're going to store a literal in this token whose value is 5. And then later we find another one whose value is 3. Right? So it varies.
But then
Yeah,
later
it's
than
going
that,
to
we
be-
find
it's
one
going to be
who's
different token types. It's going to be different token.
Yeah, it's going, yeah. So
I think what you're saying is Java has this magical type called object that can hold either one, right?
oh yeah, that's not the problem. So
Okay.
if we wanted a magical type that can hold either one, we make this enum. So it'll either be a what is it? String containing this.
What's wrong with putting this inside the
Or a
literals
number.
inside token type?
Oh, now I see what you're saying. Sorry. That took me a while. So you're saying here, if it's a
Yes.
string literal, then it contains a tick a stir.
Yep,
And if it's a number, it contains a F64.
F64.
Cool.
And same for identifier.
All right. Sorry it took me this long, but no.
No worries.
All right, so token contains that.
Lifetime.
I think I still want to have lexeme separate.
Okay,
Um,
that's fine.
and then line. Oh, you mean here? And then line is just a
Use size.
view size. And this has the same lifetime. Great. Okay. Well, that is a decent start, I guess.
Yeah, this is,
Yeah.
I've been learning a lot. This is great.
Yeah.
I
Thanks
think
for knowing
I'm-
everything, Michael.
I think I'm learning that it would take me a long time to ease into Rust, and that it would be difficult for me to find the patience to not just want to override it and get my freaking work done, and have it be smacking me in the face. But at least it does smack you in the face right in your IDE.
Yeah.
With very, very useful and helpful messages all the time. So if you just kind of visually watch out for the little red underlines all the time, I guess you could get quick at getting over the roadblocks.
It's
Yeah.
not
Let's
all
see if
the
it-
time. Sometimes error messages suck.
Let's see if this like works. Or token in scanner.
It will fail because we have to do instead of next.
Yes, we have a panic in next, but you know,
And we probably want to derive something like debug on token type and token.
derive like yeah, like how to print it out. Sure.
Yeah.
And of course nothing's going to work about it because we haven't told it how much of the code to consume to take it the next token, which will be I'll go in here. But it will compile and then panic. So that's cool. There we go. Not yet implemented. Cool. Well, thanks, guys. I guess
Yeah, thanks.
if you're still recording, Paul, you can stop the recording.
Okay.